Hey there, welcome back to RC with Adam. I just wanted to show you this super boring regular drone that I built. Psych! I actually want to show you this drone. It's called the Venn drone, and it's 7 times more awesome and way more interesting and unique than a normal drone. That's because I built it, and it's 3D printed, and it's like upside down, and it's really weird. So let me show you this. So I'm calling this style a crammed 5-inch quadcopter. I call it crammed because everything's kind of crammed together instead of slammed, like squished flat, which is another style of quadcopter. Fun fact. Now, you might be wondering, Adam, what the heck is going on here yet again? And you are right to ask that. So I designed this because I wanted to play around with the idea of having a large disc area in a very compact package, similar to the size of a 3-inch CineWhoop, because those are all the rage right now. We're spinning 5-inch propellers, basically all normal 5-inch quadcopter components, but in a very small frame, and the motors are inverted and the propellers are overlapping, and they're all at different heights so that they don't hit each other. And that's basically the design. So in this video, I want to bring you through how I got to this point and kind of how it flies right now. And I mean, you can see how it flies right now just so you don't have to sit through the whole video. We're just in the early stages of testing right now, so I've only done line of sight testing, but so far it's actually more promising than I thought that it would be. Now, is there actually any point to this? Is there any practical application? Maybe we'll have better performance over a 3-inch quadcopter in a similar compact format. I'm not really sure. Maybe you're seeing this and you're like, whoa, this is exactly what I needed. Leave a comment down below if it is. Now that you know the basic concept and kind of where it is right now, I want to take you through the whole process of designing this, some of the considerations that went into it, and also the components and all that stuff. We can kind of geek out a little bit. But first, I need to say thanks to my sponsor, PCBWay, for sponsoring this video. And if you guys need custom electronic parts, custom printed circuit boards, go check out PCBWay because they offer all kinds of stuff and many different options, and they get it to you pretty quickly. And what you can do pretty quickly, like how quick is that? I don't know, pretty quickly. It depends on how fast the shipping is, I guess. And what you can do is you can design a circuit board and then send those files to them, and they can create that circuit board to your specifications, which is pretty neat. Also, they offer rapid prototyping, so if you need something made of metal, either CNC machined or sheet metal, or maybe something injection molded or 3D printed, they can help you with that as well. So I'll have a link to them down in the description of this video. If you need anything like that, go check them out. Now, just to give you a little background on this project is inspired by a previous project that I did, and I made a video about that, where I took a frame designed for a 3-inch size quadcopter, and I put 5-inch propellers and motors on there. But in that case, I had the propellers and the motors on the top and everything underneath. So kind of like the opposite of what I have now. And that would have been a problem because you can't put a GoPro on top of that because you have propellers on there, and everything would have to hang underneath, and it wasn't really built for that anyway. So what I wanted to do with this one is design the frame to be 3D printable and design it around the specific use of carrying a full-sized GoPro. So let's get into it. Of course, I started by doing a basic sketch on graph paper of kind of the top-down view to get an idea of the overall spacing motor to motor that I would need for this frame. So I drew out the propeller disc size, and as you can see, it makes the shape of a Venn diagram. So that's kind of why I call this a Venn drone or Venn diagram drone or something like that. And I thought that was kind of neat. And you can see that there's a lot of overlap on the propellers, and we'll talk about that later. In any case, once I had a basic idea of the size that I wanted, I started drawing some stuff up in Fusion 360 and went through a few different prototypes and printed those out. and made sure I got all the holes spacing correct and all that stuff. I will say, with the way that this printed out, I'm pretty darn pleased with the frame. The geometry seems pretty rigid, and the hole spacing worked out pretty well. It can definitely be improved. This is just version 1, but so far, so good. So in total, I designed the frame, I designed the top mount, which is basically where the battery rests, and it protects the electronics. And then I printed some spacers as well, and that is really the key component to get these propellers to even spin without hitting each other. I designed all those, and then I printed them out, and eventually I got it right, and they printed pretty well. Ooh. And now it's time to put it all together. So the electronics that I'm using for this build, the stack is going to be the SpeedyB F7 Mini, and SpeedyB sent me this stack, so thank you, SpeedyB, because they're like, hey, we got this new stack, do you want to try it? And I said, that will probably be perfect for what I'm working on here, and with a F7 flight controller and 35 amp 4-in-1 ESC board. It is very small, just like all 20 millimeter stacks. Overall, I really like this stack, and I really like that I can connect to the SpeedyB app with it wirelessly. That's super helpful. But one thing I don't like about it, I feel like the little rubber spacers, or kind of the standoffs, aren't quite tall enough for the 20 millimeter holes, and the ESC connector would have hit the bottom of the frame, and it would have been touching the frame as I have it here. So I don't like that. So I had to improvise a little bit to create space so that none of the ESC was touching the frame and none of the flight controller was touching the ESC. Otherwise, I really like it a lot, and I really like that everything is labeled, even though it's very tiny, and that is one thing that's tricky about these tiny flight controllers, is they can be difficult to solder because the pads are so close together. But I really like that they bothered to label them. The motors are iFlight Sing 2207 1800 kV motors, and this is all built for 6S basic. And those are spinning Ethics S3 watermelon propellers. And I'm using these propellers because, one, these are kind of my go-to propellers right now. And also, as I realized later is very important, the hub is fairly thin. It's not a super thick hub like some other propellers. And so that allowed me to add extra spacers, which really saved the day. I'm using an analog VTX and an FLI 14 Plus FlySky receiver. The FPV camera is a Runcam Phoenix 2. And by the way, I did not bother designing an FPV camera mount just yet. I wasn't sure where it was going to go or what size it needed to be. So I ended up just hot gluing it in place. And to hold the GoPro on here, I'm using my custom GoPro mount that I've designed and is available on my website right now. And this is a no tilt forward design because, I mean, I'm sure you've had the situation where your GoPro slouches forward after you crash or something, and then you're just filming the ground for the rest of your awesome flight. Well, I said, that's dumb. So I just made it so you can't tilt the GoPro forward. And that solved the problem. And I made this one very low profile, and it just uses an M5 button head screw to hold the GoPro in place instead of a thumb screw. And I made sure that that was slightly off center so that we would have the lens of the camera more towards the center of the aircraft. Ready to go, all loaded up.
this thing looks ridiculous, and that's because it is.
You can see the actual battery mount kind of top cover is way taller than it needs to be, so we could shrink that down and improve that design for sure. Mounting the motors is a bit difficult because we need those spacers, so I had to play around a while to get that right. And the bottommost motor, the one that has the most spacers, it needed a 20 millimeter M3 screw to hold everything in place. And really, it probably should be even longer. Let's just get a weigh in, and let me do this upside down. We are looking at 618 grams. Fortunately, the balance point does seem to be right where the flight controller is, so I guess I got lucky there. Now we can get our phone ski doodle dandy to the SpeedyBee app. Again, don't give me an ad for an app for a product that you sold to me. Actually, in this case, you did send this to me, so that's cool. But don't do that. Don't do that to your customer at SpeedyBee. Mini, let's connect it. So that's pretty cool. It is initializing. Okay, cool. And we are connected. So this is cool. I'm going to try and do this whole setup on my phone. And then this one is spinning inward, so I actually want to change the direction. Click change the direction. Whoa, that is super easy. Good job, SpeedyBee. Good job. And then it will spin outward. What? Look at this guy. Look at that. Look at that right there. It's got a bunch of spinny blades, and they all intersect in the middle. Now, in case you haven't noticed this by now, one of the problems with this design is how do you take it off the ground? Because the propellers are just sitting on the ground, so you definitely can't do it in grass. You need some sort of hard surface so that the propellers can kind of spin. And basically you just want to take off as quickly as possible. Okay, cool. So that's what I did here. I set it on, some boards on a trailer, and then took it off. And this first test flight, as you can see and hear, it did not go so well.
Oh wow, cool. All right, nice. It's really loud. We're using a 4-cell battery, 1300 milliamp hour, I think, maybe 1500. But it seems like it works. Yeah, it sounds horrible. Seems like it's working so far. Let's just try a little a roll. Yeah, it seems to work. That's cool. Wow. Yep, they kind of hit each other a little bit.
In any case, it does fly though, so that was pretty cool. I just did a line of sight test here, especially because the propellers were making so much noise and it was just, it was so bad. I knew I needed to fix the propellers hitting each other. That's obviously a problem. So what I had to do is add spacing between the motor and the propeller. So basically put spacers on the motor shaft itself. And that worked out all right because these propellers have a nice, relatively thin hub. And I'm using some low profile lock nuts that I used on my other project, the Geared X-Class drone. And so those low profile lock nuts allow me to get that locking ability without threading as many threads. So that worked out pretty well. And then I also added my GoPro dummy, the Dumb Pro 9. Now, as you can see on this next test flight, it flew really well, and it sounded way better and way quieter. It was really weird. Like, it sounded like, I guess, probably a regular 5-inch quadcopter, you know, that's loaded down. Now, this was strange to me because I thought that if this thing is fully loaded, then I would think that there would be more stress on the propeller blades, which would cause the tips to bend more, and that bending would cause the propellers to hit each other more. But I guess since I added the extra spacing between the propellers, that solved the problem and it flew very nicely. So I'm not sure if it's because I added the GoPro or just because I added the spacing. I probably should have just changed one thing at a time, but I didn't. So anyway, it flies pretty well now. And then after flying it with the 4-cell, I've stepped it up to the 6-cell, and we definitely have a lot more punch, a lot more power. I couldn't really like fly it around like full throttle or anything. I was just doing hover tests here, but definitely like controllable, seemed fairly stable. The rates were kind of weird. I mean, the rates were high. They were just stock rates, so it felt weird trying to control it. I was able to change the rates easily with the Betaflight app, which is super cool, but I still need to play around with it to get the rates how I actually want them. In any case, this thing really turned around, and it actually started, you know, flying well. So I'm like, shoot, maybe there is something to this. If nothing else, I hope this project inspired you and got your creative juices flowing for your own project. And let me know if you have questions about this or are interested in this design. Eventually, I'll probably have these 3D printable plans for the frame on my website, because this would probably be a great 3-inch frame by itself anyway. Or maybe you just scale down this whole design into a 3-inch form factor and have a super tiny 3-inch. I don't know. Anyway, thanks for watching, everybody. I appreciate you. Thanks again to SpeedyBee for sending me their new Mini F7 flight controller. And thanks to PCBWay for sponsoring this video. Stay flying, stay frosty, and I will see you again very soon.
We get bars in our goggles that show